In this lecture, we will discuss the linearity property. We already discussed the basic concept of linearity property in the previous lectures. Now we'll do some problems related to that. We'll check whether the given systems are linear or not. We'll start with the question y of t is equal to t square into x of t minus 2. And we need to verify whether the system is linear or not. For this particular system, the input is x of t and the corresponding output is y of t. And it is given by the equation t square into x of t minus 2. And if you apply the input x of t, you will get t square into x of t minus 2 at the output side. So this is a continuous time system. So we need to use this particular formula to verify the linearity property. And in the given question, assume that for the input x1 of t, the system produces an output y of t. Then you can write y1 of t is equal to, if the input is x1 of t, the output is y1 of t. So you can write y1 of t by comparing the standard equation given in the question. It is t square into x1 of t minus 2. And similarly, for the second input x2 of t, assume that the output is y2 of t, and corresponding output you can write t square into x2 of t minus 2. Because if you apply x of t, the output is t square into x of t minus 2. Similarly, you can consider the third input, which is x3 of t, and the x3 of t produces an output y3 of t, and this y3 of t can be written as t square into x3 of t minus 2. And this x3 of t is a special type of input, which is the linear combination of the first two inputs. So you can write a x1 of t plus b x2 of t. And you can substitute this x3 of t in the previous equation. So we can write y3 of t like this. Y3 of t is equal to t square into, in place of x3 of t, you can substitute this equation. So the output becomes a x1 of t minus 2 plus b into x2 of t minus 2. And if you rearrange this particular equation, it becomes a into t square x1 of t minus 2 plus b into t square x2 of t minus 2. If you compare the first two equations, a into t square x1 of t minus 2. So we can write y1 of t here. And similarly for the second, t square into x2 of t minus 2, you can write y2 of t. And a y1 of t plus b y2 of t. So the given system is linear because the weighted sum of inputs. So here you are applying weighted sum of inputs, and you are getting output as a linear combination output, or you can call it as a weighted sum of output. So the given system is linear. Now we can verify another system. Here y of t is given by x of minus 2t into x of t plus 3. And for a continuous time system, if you apply the input x of t, the corresponding output is y of t, and which is of the form the input x of t is scaled and reversed, x of minus 2t into x of t plus 3. So this will be the output. And similarly, if you compare, if x1 of t be the input and the corresponding output is y1 of t, and this y1 of t you can write in terms of x1 of t like this, x1 of minus 2t into x1 of t plus 3. Similarly, for the next input x2 of t, the corresponding output is y2 of t, and you can write this y2 of t like this, x2 of minus 2t into x2 of t plus 3. And if you compare the third input, x3 of t as a third input, and the corresponding output is y3 of t, which is equal to x3 of minus 2t into x3 of t plus 3. And in place of x3, we will write the linear combination of input. So we will write a x1 of t plus b x2 of t. Assume that the third input is a x1 of t plus b x2 of t. And in place of x3 of t, if you write this, you will get another equation. Uh, in place of x3 of t, you can substitute this. So y3 of t becomes a x1 of t, sorry, x1 of minus 2t plus b x2 of minus 2t into, in place of this x3 of t, you can substitute a x1 of t plus 3 plus b x2 of t plus 3. And if you multiply this, you'll get different terms, and you can compare this equation with a y1 of t plus b y2 of t. If the system is linear, it should be in this particular form. If a y1 of t, you can write because already y1 of t is written here, so it becomes a x1 of minus 2t into x1 of t plus 3, and plus b into x2 of minus 2t into x2 of t plus 3. And if you compare these two equations, we can conclude that which is not equal to a y1 of t plus b y2 of t. So we can conclude that the given system is non-linear because it does not obey linearity property. If you can write the given equation in this particular format, then we can call it as a linear system. In this particular question, we cannot write as a linear combination of output. The system is non-linear. Now we can verify y of t is equal to cos x of t. And for this given system, if you apply x of t as the input, you will get cos of x of t as the output. That is y of t. Now we can verify the linearity property. If the given input is x1 of t, the corresponding output is y1 of t, and you can write it becomes cos x1 of t. And for the second input x2, the corresponding output is y2, and you can write it becomes cos x2 of t. Now we can consider the third input x3 of t, and the corresponding output is y3 of t, and you can write that y3 of t is equal to cos x3 of t. And in place of x3 of t, we'll write x3 of t as a linear combination of the first two input a x1 of t plus b x2 of t. In all the cases, you can write x3 of t like this because that's a linear combination of input. And here you can substitute x3 of t. So y3 of t becomes cos. In place of x3, you can substitute. So you will get a x1 of t plus b x2 of t cos of a x1 of t plus b x2 of t. And if you split this, it becomes cos a plus b, which is not equal to a y1 of t plus b y2 of t, because a y1 of t plus b y2 of t is equal to cos a cos x1 of t plus b cos x2 of t. That is a y1 of t plus b y2 of t. And the given equation is not in this particular format because this is cos a plus b, which is not equal to cos a plus cos b. So the given equation is not satisfying the linearity property, so we can conclude that the given system is non-linear. Now we can compare another question. Y of n is equal to modulus of x of n. Okay, it's again very important. For example, if you are applying an input x of n and the corresponding output is y of n, which is the modulus of the given input. For example, if you are applying minus 2, you'll get 2. Okay. And for the input x1 of n, the corresponding is y1 of n, and you can write it's a modulus of x of n. And for the second signal, it's modulus of x2 of n. And assume that the third input x3 of n is a linear combination of the first two input a x1 of n plus b x2 of n. And if you apply y3 of x3 of n as the input, then y3 of n becomes modulus of x3 of n, okay, which you can write a x1 of n plus b x2 of n modulus, and the whole modulus. And the given expression we cannot write like this, which is not equal to a, what we can call a into modulus of x1 of n modulus plus b into uh, modulus of x2 of n, because we cannot split this modulus sum like this. I'll give you a simple example, uh, because assume that x1 of n is minus 2, okay, and x2 of n is equal to 2. And if you take the modulus of x1 of n, it becomes modulus of x of n, x1 of n, it's equal to 2, and modulus of x2 of n is equal to 2. And if you perform x1 of n plus x2 of n, then you'll get 2 plus minus 2 plus 2, which is equal to 0. And if you take the modulus of x1 of n plus x2 of n, it's simply 0. And individually, if you perform this operation, you will get 4. That is, if you take the modulus of x of n plus modulus of x2 of n, it becomes 4. So that's why we cannot write equal to, and which is not equal to a y1 of n plus b y2 of n. So we cannot write, don't confuse, this is not equal, not equal to the linear combination output. So the given system is a non-linear. It's a non-linear system. The modulus operation is a non-linear operation. Now we'll compare the logarithm of x of n. For this discrete time system, if the input is x of n and the corresponding output we can represent by the letter y of n, and which is the logarithm of input signal x of n. And for the given input x1 of n, the output is y1 of n, and you can write this y1 of n by comparing the standard equation log x1 of n. And similarly for the x2, you can write it as log x2 of n. And if you compare the third input x3 of n, which gives y3 of n, and y3 of n can be written as log x3 of n. And assume that x3 of n is in this particular format, a x1 of n plus b x2 of n, because it's a linear combination of the two inputs. And in place of x3 of n, you can substitute this expression. Then y3 of n becomes log a x1 of n plus b x2 of n. This expression we cannot split into two like this, because if it is like this, a y1 of n plus b y2 of n, linear combination of output, means it should be in this particular format, a into log x1 of n plus b into log x2 of n. But the given equation is not in this particular format. We cannot split this logarithm into a into log x1 of n plus b log x2 of n. So the given equation not in the format y1 of n plus b y2 of n. So we can conclude that the given system, the logarithmic system, is again a nonlinear system. Nonlinear system. This is another system which is y of n is given by sigma k is equal to minus infinity to n x of k. Previously we discussed another question in the case of continuous time system, that is y of t is equal to integral minus infinity t x of tau d tau. So this is a discrete time version of this particular question. This is summation similar to integration, and now we need to write the y1 of n in terms of x1 of n. So you can write k ranges from minus infinity to infinity x1 of k, and similarly you can write y2 of n, k is equal to minus infinity to not infinity, it's up to n x2 of k. The two signals you can write in the form of summation. And now we can consider third signal x3 of n, and the corresponding output y3 of n you can write like this: sigma k is equal to minus infinity to n x3 of k, and assume that the x3 of k or x3 of n is a linear combination of a x1 of n plus b x2 of n. It's a linear combination of the two signals. Now in place of uh, this equation you can write uh, in x3 of k. So we need x3 of k. You can replace this n with k. You can write y3 of n is equal to sigma k is equal to minus infinity to n. Uh, in place of x3 of k, you can substitute this equation. So you can write a x1 of k plus b x2 of k. And summation is common, and the variable is k. You can split the summation, and you can write sigma. You can write a into a is a constant, k is equal to minus infinity to n x1 of k plus b is a constant, sigma k is equal to minus infinity to n x2 of k. And if you compare the first two equation, this is simply y1 of n. We can write a y1 of n plus b y2 of n. So the given system can be written as a linear combination of output for the given linear combination of input. So the system is linear. So you can conclude the given system is a linear system. And here y of n is given by x of n by x of n minus 2. And for the input x1 of n, assume that the output is y1 of n, and you can write it becomes x1 of n by x1 of n minus 2. And similarly for the second input, it becomes x2 of n by x2 of n minus 2. And you can consider the third input x3 of n, which you can write a x1 of n plus b x2 of n as a linear combination of two inputs, and the corresponding output for this x3 of n is y3 of n. So y3 of n can be written as x3 of n by x3 of n minus 2. And in place of x3 of n, you can substitute this equation. So it becomes a x1 of n plus b x2 of n in the numerator, and the denominator is a delayed version. So you can write a x3 of x1 of n minus 2 plus b x2 of n minus 2. But if you y the output as a linear combination, that is a y1 of n plus b y2 of n. It will be like this: a into x1 of n by x1 of n minus 2 plus b into x2 of n divided by x2 of n minus 2. And if you compare these two equations, okay, assume that this equation number 1 and this equation number 2, we cannot write 1 in terms of 2. Okay, we cannot split this output as a linear combination of a y1 of n plus y b y2 of n. So we cannot write, which is not equal to a y1 of n plus b y2 of n. So we can conclude that the given system is non-linear. It's a non-linear system. Okay. So these questions are very important. Please go through all these questions.